Hey everybody, so today we're going to be talking about mass movements, so different types of mass movements. So what we're going to be doing today is going over mass movements and the different types. We'll also talk about why mass movements happen. We'll talk about sort of the major mass movements, how they can also happen underwater, and then some hazards and what we do to try and keep ourselves safe. So a mass movement, which can also be called mass wasting, it's pretty much the same, is any sort of downslope motion of rock or debris or snow or sediment or ice. So any downslope or downhill motion of sediment, of land, of rock. And this is usually caused, there must be some sort of instability that allows for that sediment and rock to break, and then also some sort of disturbance that starts the mass movement. So that it's already unstable, and then there's something that happens, some disturbance that actually starts the mass wasting, starts that mass movement event. So regolith is a word that we talk about for any sort of soil, sediment, and debris. So regolith would be anything that can fall down sort of in a mass movement, in a mass wasting event. We would have downslope motion of our soil, sediment, debris. It's not necessarily one, so it's not going to be just soil or just tree trunks and tree branches or just small sediment. So we use regolith to talk about the combination, any sort of combination of all of them. So something important to recognize about mass movements is that they're becoming more and more of a threat over time to us. So for humans, for towns, for cities, for our safety, mass movements are becoming almost worse and worse in terms of potential danger. And the main reason for that is because of our population growth. So cities are expanding, not only in number of people, but also in surface area. So with more people, cities have to expand, towns have to expand outwards, meaning that sometimes people end up settling or building roads and homes and towns in unsafe areas. So in the areas that maybe aren't the most desirable in terms of mass movement potential. So the more and more that we are growing in terms of population and spreading out, the more and more potential we have for mass movement threats and mass movement dangers. So to start, let's go over a couple of different types. So landslides is any sort of mass movement of rock or regolith. So any sort of downslope movement would be a landslide. The different types, if you can't determine specifically what type, you would just call it a landslide. But you can also be more specific by thinking about the type of material. So is it large boulders or is it mud? Things like that. The velocity, so how fast does something like this happen? Also, how does it flow? So does it roll down the hill? Does it flow with water? And then also the environment, where the movement occurs. So what's going on? What type of environment are you in? There can be rock slides and debris slides as types of landslides. Rock slides would be something made of larger rocks. So if you have tumbling boulders that fall down, that's generally a rock slide. Usually it's also dry. So if you have large pieces of rock sliding down, not associated with water, you generally have a rock slide. A debris slide is usually lots of debris involved with water. So I'll show you some videos. Debris slides generally have water involved. But there's many different scales. So there's all sorts of scales of landslides, but they pretty much always leave a scar behind. So some sort of landscape scar on the slope behind it. So even looking back in time and then looking forward in time, which you're going to do on Google Earth in your lab, you'll actually be able to see the scar or the marking of the landslide. So some types of mass movement that we're going to go over. I have some videos. This is sort of in a good order when we talk about speed. So we'll start with creep and slump, and then we'll get to the different rock falls and debris falls. And then we'll talk just briefly about the types of mass movements that can happen underwater. So the slowest type of mass movement is called creep. So this is because the land is creeping. It is not a fall that happens right away. This is something that happens over time. So it's a really slow downhill movement. So as you can see, the particles actually, when the ground expands, so when there's water involved, which means the water freezes and the land will actually expand, you have this particle. As the land expands up from that freezing, we have the particle rising up. So this is the wintertime position when the water within this area of land actually freezes. And then when it thaws, so the land shrinks back down, thaws, now it's water instead of ice, it's going to sink straight down. So then the next year, as the water within this land freezes, our particle is going to move straight up because the whole surface rises up in the winter due to that freezing. And then as we thaw, this particle is going to drop straight down. So you end up with this zigzag pattern, which actually says, over time, this particle is going to end up down here. So what happens is you have something that looks like this. So you end up with actual creep downhill because of the seasonal freezing and thawing. Seasonal wet season, dry season, freezing, thawing. We have that upward in terms of perpendicular to the surface when the wintertime is freezing, and then dropping straight down, gravity-wise, in terms of when we are going from winter to summer, when things are thawing out again. So it can look something like this. We have slow creeping downhill. So this is the creep zone where we have that freeze, where we have that thaw. Things will end up actually tilted. So we generally see tilting. If it happens over many, many, many years, you can actually see this curving of the tree trunk due to the creep, which is really cool. You might have seen, here's a picture. So they use some of these in movies often, the creeping trees. So this is due to creep. This is due to that very slow seasonal creep downhill. So this is something that happens on really long time scales. This is not something that happens right away. So this is actually going to be over many seasons, many years, we would see creep. Another is called slump. So slumping is when we have actually sliding of blocks of rock. So it's not necessarily a fall all the way down the slope. It's some sort of slumping along a curve. So here we have our failure surface. So this along here, if you can see my laser pointer, this is the failure surface where the slump occurs. So the land used to be along this dotted line, and it is slumped downward. So we usually say that it causes a spoon shape. So the curve, the failure surface must be this curved spoon shape. And we end up with a visible scar. We call this the head scarp. This is the visible underneath layers that are now visible now that this slump has happened. And we also have accumulation down here at our toe. So for all mass movements, we have a head and a toe. So the toe being the bottom, the head being the top. Now I think that comes up in your lab as well, the toe versus the head. So this is generally, this is not necessarily multiple blocks of land. It's called a slump because we have one mass of land sliding down. So this is sort of one big giant piece that slumps and slides all at once. It's not like a landslide or a rockfall where you have sediments and regolith and debris all combined. It is just one big, or it can be multiple large pieces. So here we have some faulting here. So these have broken into smaller pieces, but they're still generally very large. We don't have any loose sediment. This is all a mass of rock that slides down all at one piece. So that is slumping. It might end up looking like this. So here we have the head scarp. So this is the head, this is the visible head scarp, and then this is the area that slumped downwards. So it didn't fall all the way down onto this road, thankfully. I believe this is in California, but it did slump a little bit. So I would be pretty nervous about this road coming up. I'm sure there were some engineers on this hill fixing the catastrophe that this could be if it slumped further. So next we have mud flow, debris flow, and lahar. They're pretty similar. The speed of these mass movements really depends on the slope, so how sloped is the surface, and also if there's water. So generally, mud flow, debris flow, and lahars occur in a river channel where there's water. It's already going downhill in a valley, so the mud, the debris can accumulate there. It's all going to naturally flow down that river channel anyway. And then you'd expect when this flow reaches the base, so reaches the flat area at the bottom of the slope, it's going to spread out like this, and it's going to drop all of this material as the surface flattens out. So here it was very steep, the water was flowing quickly, allowing all this debris to flow downhill. Once it got to this more flat area, the water slowed down, which means that the larger pieces, so you can see these are pretty huge pieces of rock that were brought down by this debris flow or mud flow. So all of that water slows down when we get to the base, and the material drops out. So we end up with this very broad area of material that's dropped at the base of the river, at the base of the mountain. So a mud flow we see this a lot in more tropical settings where there's a lot of rain because it is mud. So when we're talking about a mud flow, we're talking about just mud. So really it's just sediment and water. So there has to be a lot of weathering for there to be a lot of unconsolidated sediment. Whereas something here doesn't have as much weathering, it's a lot of big rocks. That wouldn't necessarily be a mud flow because it's not just mud. So we would be looking for a tropical area that has a lot of rainfall to cause weathering, and then also a lot of rainfall to saturate the ground. Because a mud flow is just a river of flowing mud. So let's watch this video. Where is it? This one. So this is a mudslide. It's a good thing they're getting out of the way. They jumped in their boat real quick. And wow. So there's a lot of water involved. It's picked up quite a bit of debris along the way. You can see those tree trunks moving. But you'll notice that the water and the mud, whew, that was close, follow what was already a stream. So that was already the way that the water flowed from the top of that mountain into this lake. And all of this material now followed down that valley as well with the water. So that could have been really bad. They didn't have a lot of time to get away. Thankfully everybody's okay. Okay, so that was a really good example of a mud flow. So now let's talk about a debris flow. I'm telling you, I have a lot of videos today. They're just too cool to not look at. So a debris flow, so this is pretty much the same thing. However, it has larger pieces of rock. So this is the same photo that I was showing before. A debris flow is where you would expect not just mud. So it's not just mud. So this can be even worse because it can be carrying boulders. It can be carrying tiny pebbles, but also boulders. And definitely it'll take down some shrubs and some trees and whatever it finds in its path. Oops. So let's watch another cool video. Oh yeah. You can see how fast the water is moving and these huge rocks that it's carrying with it. Those are giant boulders flowing down this valley. These guys are a little too close for my personal comfort. Look how big that boulder is. Wow. That is terrifying. Absolutely rushing down that valley. So again, it's already in the valley. It's in the area of the stream. And it's even causing more erosion along that stream because the water is moving so quickly. Those are, I don't know, as big as my car. That's crazy. Wow. So that is a very serious rock flow that is carrying absolutely huge boulders downhill. So next we have lahars. Come on, computer. There we go. So a lahar is something that I think we briefly mentioned when we talked about volcanoes, but a lahar is strictly involved with volcanic eruptions. So during an eruption, that volcanic ash and dust-sized particles that's emitted from the volcano can actually mix with water. So generally, a volcano is rather high, so you'll notice here it's white, it's covered in snow. So there's already melting occurring. So any water that falls on the top of that volcano, it's going to make its way down. So there are stream valleys for water already occurring or already in place on the top of volcanoes. So what can happen is when there is a volcanic eruption, that volcanic ash mixes with the water that's already there, either from rain or from snow and ice that's being melted during this eruption, and it's going to flow down the river. So this can be really, really, really horrible and very devastating because it's poisonous, oftentimes poisonous volcanic ash flowing like a landslide, like a mudslide down a river valley from the volcano. So those can be pretty terrifying, and they can actually spread a lot further than the lava can. So often the danger of the lahar spreads further from the volcano than the danger of the lava, because the lava is not going to flow as quickly and it's not going to flow as far, whereas this is really just volcanic ash mixed with water. It can flow just as far as water can. So this can be really, really dangerous, and it can get into water systems. The next is an avalanche. So an avalanche is oversteepened snow. So this is where we have actually snow falling down a slope. So an avalanche is always snow and ice. It's not necessarily rock. It's where we have a thick area of snow that is too steep, and it actually will detach from the side of the mountain or from the peak of the mountain. So avalanches usually occur in the same areas every season, every winter season. So once an area is mapped out for avalanche potential, we know where the avalanches will occur year after year, because snow forms the same way, because it's going to form based on the shape of the mountain. So it's usually in areas that have no trees, because it will fall sort of as a slab down the mountain. So we look for no trees, and we look for perfect little chutes for the avalanches. So these can be really, really dangerous for people that get caught in them, because they move very, very quickly. So there's two types of avalanches we call a wet and a dry. So a wet avalanche is something where it flows more thickly, so there's more water involved. It's usually thicker, wetter snow, and it's going to move a lot slower, and it will flow down slope like a river. So it sort of hugs the side of the slope and flows down like a river. Whereas the more dangerous type is a dry avalanche, where it's really just powdery snow that's falling. So this is where we have a lot of snow flowing downhill. It's going to move incredibly quickly, and it can rise up sort of in clouds. So it can be much more dangerous because it can reduce visibility for anybody around. all that dry snow is going to flow downhill. Downhill of that avalanche. So the dry avalanche, where you have that fluffy snow sort of flowing and billowing downhill, is going to be more dangerous than the wet avalanche. If you're too close to either of them, the danger is pretty equal. However, the dry avalanche is more dangerous because it is more dangerous for a larger area. So it covers a larger area. Let's watch a cool video. This one, and then there's one more after this. So here they are using snowmobiles. Not great because they cause an avalanche. So he's going up. So notice there's no trees here. And that whole slab of snow is falling down with him. So that is a dry avalanche, where it billows up like clouds. It looks more like a dust, like a solid, rather than water flowing. So again, that is a dry avalanche there. So it's the snowmobile, the vibration of the snowmobile on the snow that causes that mass movement to start. Okay. All right. Last one. Avalanche, be careful if you're a skier. And then I also want to show rock falls. So rock falls can also be called a debris fall because it's not always rock, but this is where we have a vertical free fall. So this is where a mass of rock regolith actually falls sort of off of a cliff. So not necessarily down a hill, but off of the side of a cliff. So that's where we get that free fall term. So it falls directly downward. It doesn't flow necessarily down a hill. So here's the scar of the rock fall. All of this fell directly straight downward, landed here, went into this lake here. So here we have the same rock fall from this cliff side, falls directly down, and then it's going to slide down a little bit to here. So the last video of today. This one is in Zion Canyon, if you guys have been there. So it's a news report talking about this crazy rock fall. So here's the rockfall occurring. Here's the bus escaping just in time. So that is, that was a large amount of rock that fell directly downward on that cliff face. So you saw sort of a big cloud. That is all the dust and debris that was sent into the air as it was falling. But the rock fell directly down that cliff face. You do not want to be there during a rock fall. So some of these also can happen underwater. So we can have submarine slumps, submarine being underwater. So slumps, where we have our blocks slipping downward, but they remain that one solid block. Also, debris flows can absolutely happen underwater. And turbidity currents. So we talked about these a little bit, where the sediment in the water can cause turbulence, so lots of circulation, and it's going to cause a graded bed, which means the large grains are going to settle out first, and then the medium grains, and then the tiny grains. So you end up with a graded bed, which means the larger grains are at the bottom, the tiniest grains are at the top, because those large heavy grains settled first. So most of these things can happen underwater, almost the same way that they happen on land. So here is a really nice image from the textbook. So it shows the different types of mass movements, and they're arranged by speed. So here we have our slump and our creep, which are on the slow side because those happen very slowly. Here's more slumping. Then we have the lahar and the mud flow, and our rock fall, which is the fastest because that happens all at once without the need for water. These two, lahar, mud flow, and also debris, they flow with water generally.